Okay, today the lesson, right triangle trigonometry, is the same. Most of it's the same as you probably had if you had trigonometry before. I mean, I know you had some of this even in geometry. This is what you did, was right triangle trigonometry. And then it might have been repeated at the end of Algebra 2. This is mostly the same stuff. By right triangle trigonometry, what we mean is this is where we're using the lengths of the sides of a right triangle to have all these relationships between angles and sides. So you could see one angle is a right angle, and if this angle is a right angle, then what do you know about the other two angles? Are they going to be more or less than 90? They got to be less, right? Because all three add up to 180. If that one's 90 by itself, then the other two angles are always acute angles. So you know that this angle theta has got to be anywhere from 0 to 90. It can't be, well, actually, it's going to be in between 0 and 90. Okay. Which in terms of like what we did in the last lesson, where we were actually going all the way around the unit circle, and we had some values that end up being negative. I mean, in this case, you're not. Because with the angles between 0 and 90, you're only in the first quadrant. X is positive, Y is positive. The other difference with what we did in the last lesson is when you're dealing with the unit circle, what's the value of the hypotenuse? It's always 1, right? It's a unit circle, so the radius is 1. But this one, the hypotenuse, this is for any size triangle, right? And then these are the definitions for the 6 trig functions. Slightly different than the ones we used last class, but consistent. Again, you got to remember the opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, whatever way you do, and then you need to know which one of them flips to become the reciprocal functions. And how many of you use like SOHCAHTOA to remember in some way? This is the one that we used when I was a kid. O-A-O-H-H-A. We would say, Oliver and olive oil have had algebra. Opposite over hypotenuse, sine, adjacent over hypotenuse, cosine, opposite over adjacent, tangent. And I used to use that all the time. You'd find in my papers, OAO, HHA. So, for example, these are the typical kind of problems you're going to get. You're not going to get 3 sides of a triangle. You're going to get 2 sides of a right triangle. How are you going to find the third side? Pythagorean theorem, right? So you're going to have to first you're going to say this side here is the square root of 3 squared plus 4 squared, which is the square root of 25, which is 5. And we should recognize 3, 4, 5 is a Pythagorean triple. Okay. Once you've filled in that missing side, now you can find the 6 trig functions. Right? So sine, cosine, tangent, and I'm going to fill in that the cotangent is across from the tangent, but which one is across from the sine? Is it secant or cosecant? Cosecant. Cosecant is going to be the flip of the sine. And the secant is the flip of the cosine. Okay, so let's see, the sign should be what? Opposite over hypotenuse, 4/5. Okay, the cosine is adjacent. In fact, one thing you might do, if you need to do it here, is just label your sides so that they are what you want them to be, right? Like across from this side should be the opposite. The next to this angle should be the adjacent. And the hypotenuse is always the hypotenuse. So the sine was opposite over hypotenuse. The cosine is adjacent, 3 over hypotenuse, 5. And the tangent would be opposite over adjacent, 4/3. Right? And then the 3 reciprocal functions just mean flip them. 5/4, 5/3, and 3/4. Now, what are all of these answers? What do they represent? Are these angles? Is 4/5 an angle? What is it? It is a ratio of sides, right? Remember, what do you put in to the sine function? Angles. Never put 4/5 into that. I see that happen a lot of times on tests. That you get the ratio, you see all the sides there, and you think somehow I'm supposed to take that 4/5 and put it in, and then put it in the calculator and take the sine of 4/5. No. The sine equals the ratio of sides. You don't know what the theta is at this point, and it doesn't matter. You know that the sine is the ratio of the length of the opposite side divided by the length of the hypotenuse. So, make sure you don't try to stuff these numbers into there. They don't go. Only angles go in here, and that's a ratio of sides. So, any questions on that? Okay, same deal. We want to do the 6 trig functions for this one. What do I need to do first? Pythagorean theorem. Okay, now, this side, right, this side here should be the square root of 4 squared minus 2 squared. Right, so that's the square root of 12. And you can simplify that. That is 2 times the square root of 3. Okay, now we're going to do all these here. Sine, cosine, tangent, cosecant. I do that every time. Okay, so the sine should be, I'll label this, adjacent, opposite, hypotenuse. The sine is, be consistent here, 2/4, which is 1/2. So what does that make the cosecant, since that's so easy? 2. The cosine will be 2√3/4, which is √3/2. Okay, and that would make the secant the flip of that, right? 2/√3. And I think I still have that on the board. What do you got when you rationalize the denominator? 2√3/3. And let's see. The tangent would be the sine divided by the cosine, or sorry, we're doing this stuff here. We're going to do opposite over adjacent, 2 over 2 root 3. Right? And that equals 1 over the square root of 3, which is square root of 3 over 3. Okay, what does that make the cotangent? I mean, yeah, if you take this and flip it, now you got to rationalize the denominator again. Why not just take that and flip it, since they're the same? That's the square root of 3. Now, what you're going to see in some of the homework problems that you're going to see, and some of the test questions, it says specifically exact, right? Which means no decimals. If something says find the exact value, then do not use decimals. Okay. If there's a square root of 3 in it, it's got to be the square root of 3. Don't try to have done something to get around all the rationalizing of denominators and things like that. So exact means exact. So there's going to be some homework problems that are more like this, right? Which is, they're not going to give you the triangle missing a side. They're going to give you that the cosine equals 5 over 6. Now with that, you should be able to draw your triangle, right? The triangle would look like, right, draw your theta, and since the cosine is adjacent over hypotenuse, that's telling you that this side is 5 and this side is 6. The cosine adjacent over hypotenuse, 5, 6. So once you've labeled it, now you can use Pythagorean theorem, find the missing side. Right? This one is the square root of 6 squared minus 5 squared, which is the square root of 11. Sine, cosine, tangent, cosecant, secant, cotangent. So what is the sign? Opposite over hypotenuse. Square root of 11 over 6. Okay, flip it. What's the cosecant? 6 over the square root of 11. Rationalize it. 6 times the square root of 11 over 11. Cosine. Cosine we were given, right? So 5, 6. What is the secant? Flip the cosine to get 6 bits. Okay, tangent should be opposite over adjacent, root 11 over 5. And then the cotangent would be the flip of that, 5 over the square root of 11, which is 5 root 11 over 11. Okay, next one. Boom. Okay. So again, if you get a problem like this, what do you have to do first? Draw the triangle, right? Draw the triangle. There's my theta. If tangent is 4/5, then that would be opposite over adjacent. 4 over 5. Okay, so draw the triangle, label the sides, then what? Pythagorean theorem for this side, right? What will the Pythagorean theorem? The square root of 4 squared plus 5 squared, which is the square root of 41. And then write them all up. Sine, cosine, tangent, cosecant, secant, cotangent. Okay, so the sine would be opposite over hypotenuse. 4 over the square root of 41. Rationalize. Rationalize. Can't have a square root of 41 in the denominator. 4 root 41 over 41. Okay, what is the cosecant? It's the flip. Just take this one, right? Don't use that one. Use this one and flip it. Root 41 over 4. The cosine will be adjacent over hypotenuse. 5 over the square root of 41, which means this will be root 41 over 5. And this will be 5 root 41 over 41. And then the tangent is given, 4/5. The cotangent is 5/4. Any questions? Okay, their next couple examples. I'm not gonna do them because what they've done is when they developed their unit circle, they didn't use the right triangle, the special right triangles like we did. You know, now they're trying to like go back and do that. When you get problems like this that are using unit circle values for the angles, right? Then by all means you're going to use the unit circle, right? If you want to know the sine, the cosine, and the tangent of 45 degrees, right? There's the sine, there's the cosine, and that divided by that, there's the tangent. Just read it off the unit circle. And if it doesn't say it, I mean, you should still assume that's exact, right? Don't just give decimals. That just means you put it in the calculator. It doesn't really show much understanding, right? Since it's a unit circle value, I would know that's root 2 over 2. Root 2 over 2 and 1. And then the 30, 60, 90, again, 60 degrees on the unit circle is right there, 60 degrees. Sine, cosine, tangent. Sine, root 3 over 2. 1/2. Oh, actually, this is sine and then cosine. And then it said sine and cosine of 30 degrees. Okay, well, that just flips them. 1/2 root 3 over 2. And they have more in this about using the calculator in terms of degrees, minutes, and seconds. Right? There will be some where all you're doing is put in the calculator to find the value, define the value. But you got to remember, where do you find the degrees? Where do you find the minutes? Where do you find the seconds? Where do you find the degrees and the minutes? Angle, right? Second, angle. The first one is degrees. The second one is minutes. Where do you find the seconds? Alpha plus. Right, that's that. Clear. And then how do you deal with these reciprocal functions like secant? You can't put the secant directly in the calculator, so how else are you going to do it? It's 1 over the cosine or and that's the reason I put this on here, because they definitely do show using the x to the -1 button for doing that. I mean, you still have to remember that it's 1 over cosine, or else you wouldn't know what to put in here. But you either do 1 divided by the cosine, or you put in the cosine and then hit the x to the -1 button. So there's a few homework problems to just repeat a little bit more. It should be a little bit of a repeat of what we did in the last lesson. Just make sure you do it and you check your answers and you're getting the right answers, so that we don't just have an issue with how to enter things in the calculator. Okay. Now these are called identities. These are the fundamental identities, which I'm going to present right here, but we're not going to do anything with them now, because the next chapter we start out with all of the identities. But I can't say that, we don't actually use these a little bit along the way. I mean, in a way, like we say sine is 1 over the cosecant. Yeah, we're kind of already saying that's a flip, right? Cosine is 1 over the secant. Tangent is 1 over the cotangent. And then they just restate those, opposite way. The tangent is actually the sine divided by the cosine. The cotangent is cosine divided by the sine. I mean, just think, if the sine is opposite over hypotenuse and the cosine is adjacent over hypotenuse, then the divide by hypotenuse drops out, and all you're left with is opposite over adjacent, which is the tangent after all. So tangent is sine over cosine, cotangent is cosine over sine. And then these here we'll do more with later, but sine squared plus cosine squared equals 1. That's a Pythagorean theorem. If we go into the unit circle, since the radius is 1, this is like saying x squared plus y squared equals 1 squared. It's a Pythagorean theorem. So, but I didn't assign any of the identity kind of stuff, which will dominate what we do in the next chapter. The last couple things are kind of wordy problems with right triangles, right triangle trigonometry, and these are, repeats. You should have seen these terms before. Angles of elevation, angles of depression. The thing to keep in mind is, whether it's an angle of elevation or an angle of depression, the angle, one side of the angle is a horizontal line. It's always an angle with the horizontal. Right, so there's the horizontal line, there's the horizontal line. Right, the angle of elevation is, you obviously are looking up to some object that's in the air. Right, that's what we mean by the angle of elevation. You might as well, if it says angle of elevation, just draw a side which is horizontal right away. Right, and then make your other side is somewhere above that, and then start labeling a triangle. If it says angle of depression, draw the horizontal line. Draw a line below that, and then start setting up your triangle. So angles of elevation and depression are with the horizontal. So typical angle of elevation, right? A surveyor is standing 115 feet from the base of the Washington Monument, okay, as shown in the figure. The surveyor measures the angle of elevation to the top of the monument as 78.3 degrees. How tall is the monument? Let's see. Just going to show up. So here's our right triangle. It's not going to work very well if you don't see these lines. Right, the 115 feet is this side right here. And the angle of elevation, they said is this. So notice the angle of elevation, one side is a horizontal line, and then the other side is above it like that. And they've labeled that as 78.3 degrees. Now, which side are we trying to find? That side right there. Right? So we want to set up a trig equation. Okay, If the angle is here and the two sides that we're dealing with are here and here, then which trig function are we going to use? Is it sine or cosine or tangent? It's opposite and adjacent. Which one uses opposite and adjacent? Tangent, right? So you gotta first, with respect to the angle that you are using here, you got to identify your sides as being opposite, adjacent, or hypotenuse, right? It's 2 out of the 3. And this one is opposite and adjacent. So use tangent. So we're going to say tangent of 78.3 degrees equals y divided by 115. Solve for y. How would you solve for y? What's that? Angelina? You're going to multiply both sides by 115, right? I mean, it shouldn't be that tough. Now, here's where you could make a mistake, right? Don't multiply 78.3 times 115. The 78.3 is inside the trig function. You can't multiply that by 115. You're going to end up multiplying here. So y equals 115 times the tangent of 78.3 degrees. Okay, let's get up our calculator. Clear. So if I just put it in straight away, 115 tan 78.3 it says it's negative 28.1 feet high. What's the matter with that? I don't have it in the right mode, right? So you got it. Since there's a degree symbol on there, we know that the angle we're putting inside is in degree mode. So we have to go to the mode here and change it from radian to degree. So go down, enter, and now go back to the screen, do it again, 115 tan 78.3, 555 feet. That sounds more like it. You okay with that? Is that really what the Washington Monument looks like? What's wrong with that picture? What's that? A lake? No. It's not like on a flat piece of ground. It's like on the top of a hill, right? It's not exactly. I mean, you could still kind of, if you went far enough away, you could still kind of figure out what you need, I guess. But it's actually, on a big mound. Yeah. Okay. And then everybody's favorite skateboard ramps. Okay, find the length C of a skateboard ramp, which is in the figure below. Now, what you can't see is that this, let me write this in a different color that shows up, says 18.4 degrees. So, back to blue. So again, with respect, we are trying to find C. Okay. So with respect to this angle of 18.4, which two sides are we dealing with it? Are they opposite, adjacent, or hypotenuse? Opposite and hypotenuse, right? This is opposite. This is hypotenuse. And so which function do we use? Sine. Sine is opposite over hypotenuse. So we set it up like this. Sine of 18.4 degrees equals 4 over C. solve for C? How are you going to solve for C? Pierce? Multiply by? Yeah, I mean, you have to multiply the C up here. That'll make it look like C times the sine of 18.4 equals 4. And then what? And then you divide by the sine of 18.4, which is going to make this C equals 4 over the sine of 18.4. Now, what else could you have done? I mean, believe me, we make a lot of mistakes on that particular calculation when the variable's in the denominator. Another thing you could do, if it makes it easier for you, is you could like stick that sign over 1 and then cross multiply. Most students don't have problems doing that, right? So just make that. You could even like put the sign of 18.4 in the calculator first and figure out the decimal value so you're not carrying that around. I mean, any way you can do it. But in the end, you know, if it's the sine of 18.4 equals 4 over C, it's like you just switch these two. Now the C is here and the sine is in the denominator. So put that in the calculator. 4 divided by, and we're already in the correct mode, so I don't have to worry about that, sine 18.4. 12.67, I'll say 12.7. Okay, what if I wanted to solve for A? Yeah. Because with respect to this angle, this is the opposite side and this is the hypotenuse. Which of the three trig functions uses those two sides? Sine, that's why. Okay, what if you had to find A? Okay, let's see. If we had to find the A, then we could have said the tangent of 18.4 is 4 over A, and then work that out. What else could you do now since you've already figured out the C? What else? That doesn't involve trigonometry. Just use Pythagorean theorem, right? Usually, if you're solving the whole triangle and you've already found one of the missing sides, then use Pythagorean theorem for the last one, right? That wasn't really part of the problem, but A equals the square root of 12.7 squared plus 4 squared. Oops, that was wrong. Minus. $12.1. Okay. I would think most of that is review. So that's it. That's the homework. Right, the quiz next class is on 4.1 and 4.2, includes unit circle.